Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss the electronic theory of chemical bonding and how to get the concept of covalent bond. This chapter has been taken from the NCERT Chemistry Class 11 books. Today's class number is 067. As we know from the previous class, that Cozel and Lewis introduced the theory of chemical combination of atoms, which is known as the electronic theory of chemical bonding. And they introduced a octet rule, which states that atoms can combine either by transfer of valence electrons from one atom to another, either by gaining or losing, or by sharing the valence electrons in order to have an octet in their valence shell. And this is known as the octet rule. From the previous class, we know that noble gas, its electronic configuration is very stable due to having the 8 electrons, that means complete fulfilled the outer electronic shell of the atoms of noble gas, except helium. For helium, we know that the outer shell is completed by electrons, which is the 2 numbers of electrons. Now we'll discuss about how the covalent bond, this term, is introduced. Langmuir refined these Lewis postulations by abandoning the idea of the stationary cubical arrangement of the octet. In the previous class, we understood that Lewis introduced term the cubical arrangement, where the electrons he placed to form the octet. And Langmuir abandoned that idea and introduced the term covalent bond. And it is called the Lewis-Langmuir theory. And with the example Cl2, will explain this. That means chlorine molecule. Chlorine molecule is made of 2 chlorine atoms. So each chlorine atoms have configuration. Outer shell configuration is the 3s2 3p5, and this any the previous that neon configuration, it is the inner shell. So it can be written, electron configuration can be written like this, and we'll consider here 3s2 and 3p5 is the outer shell configurations of the chlorine atom. And to attain that octet in its outer shell, it needs the 8 minus 7. 7 means 3s has 2 electrons, 3p has 5 electrons, or 7 electrons. So octet formation, it needs 1 electron to get the next noble gas argon's electronic configuration, which is the outer shell is the 3s2 3p6. So 3p5 here, if we introduce 1 electron, then it will get the octet formation in its outer shell in respect of electronic configuration. So the formation of Cl2 molecule will be understood in this way. You can see that this is the chlorine atom and outer shell electrons is the number 7, and this is another chlorine atom, its outer shell's electrons also 7, and then they are sharing each 1 electron with another chlorine atom. That means 1 pair of electrons is formed, which is commonly be with this left side chlorine atom as well as for the right side chlorine atom. And this sharing of this electron pair, and it is the responsible to form the covalent bond between these two atoms. These all dots represents the electron, and this type of structure using this dot in disparate electrons, it is called the Lewis dot structure. This dot structure can be written for other molecules also, and you can combine the atoms to form molecules by formation of bonds. There are some important conditions. Number one, each bond is formed as a result of sharing of an electron pair, like chlorine molecules I showed just now, between the atoms, and each combining atom contributes at least one electron to the shared pair. The combining atom attain the outer shell noble gas configuration as a result of sharing of electrons. So these three conditions should be fulfilled to form the molecules from outer atoms in respect of the Lewis dot structure. Example is the water molecule, formation of water molecule from 2 numbers of hydrogen atoms and 1 numbers of oxygen atom. And then we'll discuss this carbon tetrachloride, which consists of the 1 number of carbon atoms and 4 numbers of chlorine atoms. So first, discuss about the H2O molecule formation. Here you see in middle one oxygen atom is there, and oxygen atoms outer shell configuration. Electrons, number of electrons is 1, 2, 3, 4, 5. 1 electron from left side and other electron right side, 6. So the outer shell configuration, electron configuration contains electrons for oxygen atom is 6. And for hydrogen, we know that it has only 1 electron. It has only 1 shell, so and only 1 electron. So these left side hydrogen atoms also share 1 electrons, and right side hydrogen also share the 1 electron. And oxygen shares 1 electron with the left side hydrogen atom and another 1 electron with the right side hydrogen atom. So 2 pair of electrons formed, and this formed bond with oxygen and hydrogen, both of the hydrogen atoms. And if you consider the carbon tetrachloride, it is CCl4, and there the carbon atom, it outer shells electrons, number of electrons is 4. 1, 2, 3, 4, and these 4, each of the electrons of the carbon atoms is shared by each of the chlorine atoms. And chlorine atoms, you know, it has the 7, 1, 2, 3, 4, 5, 6, and 1 electron, which one it already shared. And in this way, the carbon will form the bond with each of the 4 chlorine atoms. And in this way, carbon atom also form the octet of electrons, and as well as each chlorine atom also form the octet of electrons configuration. So, when the 2 atoms share 1 electron pair, they are said to be joined by a single covalent bond. That means one pair electron is shared by the two atoms, then it will form the only one single bond. So multiple bond formation also possible, because if two atoms share more than one pair of electrons, then formation of the multiple bonds is possible. The formation of multiple bonds happens by sharing of two more than one pair electron pair between two atoms. If two atoms share two pairs of electrons, so it will form the double covalent bond. The covalent bond between them is called the double bond. Example. Now we'll take the example in respect of the formation of the carbon dioxide from one carbon atom and two oxygen atoms. So here carbon, we know it has outer shell number of electrons is 1, 2, 3, 4, and oxygen outer shell it has the 6 electrons 1, 2, 3, 4, 5, 6. So for each oxygen in this figure from left side and right side, it shared 2 electrons with the 2 electrons of carbon for each oxygen. And in that way, this central carbon will form the octet electronic configuration. You can see here in the middle, whatever the egg-shaped round is there, and you see the right side 1, 2, 3, 4, left side also 1, 2, 3, 4. So this carbon atom attains the octet electronic configuration, and each atom also, if you see left side is round shape and right side is round shape. Here also you can see the 1, 2, 3, 4, 5, 6, 7, 8, and right side for oxygen atoms also it has the total 8 number of electrons by sharing the electrons with the carbon atoms. So in that way, all 3 atoms, that means 2 number of oxygen atoms and 1 number of carbon atoms, attain octet electronic configuration by forming. So here you see 2 pair of electrons is there. So that means oxygen from the left side will bond with the central carbon with 2 number of covalent bonds. That means will form the double bond. And for right side, oxygen atoms will form with the central carbon atom in same way, because it also has 2 number of electrons pairs, so it will form the double bond also. So final structure is like that. You can be seen in this figure here. Now we'll think about the another ethene. Ethene discuss about the bond formation from the Lewis structure. So central it has the 2 carbon atoms, left side and right side, and each carbon atom is attached with the 2 numbers of hydrogen atoms. So here you see also that left side carbon, it also form because it has the 4 electrons, 1, 2, 3, 4, all 4 electrons is shared by neighboring atoms. That means each carbon atom shared their electrons with 2 number of hydrogen atoms and 1 number of next carbon atoms. So this left side carbon atom forms single covalent bond with 2 number of hydrogen atoms. But when right side carbon atoms it formed the bond, then it formed by 2 number of electron pairs. So carbon it will form the double bond between them. And right side also in same way. So ultimately the figure you have seen in the right side, it can be written like this. And this is the C2H4 molecule. So in this way we understood that how a covalent bond, single or multiple bond is formed by using the Lewis structure, and with help the language concept. Now we'll discuss about the triple bond formation. So we'll take the example of the nitrogen molecule, which is the N2 molecules, and here each nitrogen has in its outer shell 5 electrons, 1, 2, 3, 4, 5. So each nitrogen atom shares their 3 electrons with other nitrogen atoms, and so in between the nitrogen atoms, the 3 pair of electrons formed. That means nitrogen form their triple bond. So 3 parallel line, horizontal line is there. It can be written like that. And another example is ethyne molecule, C2H2. That means 2 carbon atoms and 2 hydrogen atoms form the ethyne molecules, C2H2. So here also you see the carbon has the 1, 2, 3, 4 atoms. So this will form the octet form with the neighboring 1 carbon atom, and left side you can see 1 hydrogen atom also. So each hydrogen atom and neighboring carbon atom also, they will share their electrons to form the octet formation for each of them. So here also for this carbon, see 1, 2, 3, 4, 5, and 1 electron of the left side carbon atom is shared with the hydrogen atom to form the single bond between hydrogen atom and carbon atom. And this carbon atom with the neighboring carbon atoms will form the 3 numbers of electrons and will form total 3 pair of electrons, and it will form the triple bond between the carbon-carbon atom. And right side carbon atom also will share 1 electrons with neighboring H atoms to form the single bond. So it can be written here H single bond C, triple bond C, single bond H for the C2H2 molecules, ethyne molecules. Hope that you understand clearly the formation of the single bond, multiple bonds, and how it can be explained by using the language and Lewis techniques. In addition, you got the simple what is the octet rule and how octet rule is the basis for the bond formation, single bond, double bond, and triple bond. I have also Dr. Acharya Academy podcast for honors degree chemistry field education. You can go through this. Thank you so much for watching this class.